Hello, in this lecture we will find the radius of the small circle. In the drawing we have a quarter circle and inside the quarter circle we have a small circle, and we want to find out the radius of this small circle. We also know that angle BCD, this angle, equals to 90 degrees. Line segment CD equals to 2 units, or chord CD equals to 2 units, and OD equals to 3 units. OD actually is the radius of the quarter circle, so I will mark it as capital R, and O is the center of the quarter circle. So I write it down. Point O is the center of the quarter circle. Okay, and we also know, because of the fact that we have here a quarter circle, angle DOB is a right angle. It equals to 90 degrees, and again the radius, actually we have here two radiuses. DO is the radius of the quarter circle, and also this line segment, if you mark it as S, this point as S, then SO is also the radius of the quarter circle, because of the fact that O is the center of the quarter circle. So first of all we will define the center of the small circle as point P, and then we connect together points A and P by a straight line. Actually AP is the radius of the small circle. I will mark it as, I will define it as small r, and okay, so I write it down that AP is the radius of the small circle So in the next step we will join points P and B by a straight line. And we will define angle ABP as theta. So this angle is theta according to our definition. Actually, we know that BA is tangent to the small circle at point A, and AP is the radius of the small circle that touches the circle at point A. So we have tangent AB that is tangent to the circle at point A, and we have the radius AP that touches the circle at point A. And we have a rule that states that tangent to the circle is perpendicular to the radius is perpendicular to the radius at the point of tangency. So I will read the rule again. The rule states that the tangent to the circle is perpendicular to the radius at the point of tangency. So actually we know that tangent AB is tangent to the circle at point A. So the point of tangency is point A, and the radius AP touches the circle at point A. So according to this rule, the tangent is perpendicular to the radius at the point of tangency. So the tangent AB is perpendicular to the radius AP at the point of tangency. The point of tangency is A, so this angle is 90 degrees because of the fact that the tangent to the circle is perpendicular to the radius at the point of tangency. So at the point of tangency, that is to say point A, the tangent to the circle creates 90 degrees with the radius AP. So this angle BAP, is a right angle. Okay? And actually if we have circle and we have a tangent to the circle, so this tangent to the circle is tangent to the circle at point X, and we know that this is the center of the circle, so point X is the point of tangency between the tangent and the circle. Then the radius that is drawn to the point of tangency to the point of tangency is perpendicular to the tangent. So this angle is 90 degrees. Again, the radius that is drawn to the point of tangency, that is to say to point X, is perpendicular to the tangent. That is to say this angle is 90 degrees. Okay? For that reason, the tangent AB and the radius AP are perpendicular to each other because they touch each other at the point of tangency, that is to say at point A. Therefore this angle BAP equals to 90 degrees. Okay, so actually here tangent theta in the right triangle APB, in the right triangle APB, we know that tangent theta equals to AP over AB. Again, in the right triangle APB, tangent theta equals to AP over AB. But we know that AP equals to R. So we can substitute AP by R. And if we multiply this equality by AB, we will get that R, the radius of the small circle, equals to AB times tangent theta. R equals to AB times tangent theta. So in order to find out the radius of the small circle, the size of the radius of the small circle, we have to find out the value of AB, that is AB, and we also have to find out the value of tangent theta. Okay? So, in the next step, we will join together points. First of all, we will define, actually CB is tangent to the small circle at this point. We will define the touching point between line segment CB and the small circle as point X, and then we will join together points P and X by a straight line. Actually PX is the radius of the small circle, so in the next step we will focus on triangles ABP and triangle PBX. I will draw them again, and we will actually prove that those two triangles can go into each other. So first of all, I will draw those two triangles again, triangle ABP and triangle PBX. Okay? So I draw triangles APB and triangle, this is B, this is triangle ABP and triangle PBX. So we will prove that the green triangle APB is congruent to the white triangle PBX. Okay? So first of all, we know that AP in triangle APB equals to PX in triangle PBX. Both those two line segments equal to R, that is the radius of the small circle. Therefore, they are equal to each other. Then we also know that PB is a common side. It actually belongs to triangle APB, and PB, side PB also belongs to triangle PBX. So PB equals to PB. It is actually common side. It belongs to both triangles. And AB also equals to BX. AB equals to BX. AB equals to BX according to two tangents theorem. Again, AB equals to BX according to two tangents theorem. So, what is two tangents theorem? Two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So I will read the two tangents theorem again. Two tangents theorem states that the lengths of two tangents from a common external point to a circle are equal. So actually two tangents theorem states that if you draw from a common external point of a circle two tangents to the circle, that is to say, if we draw from point B, that is external point of the circle, of this circle, if we draw two tangents from point B to this circle, then those two tangents will be equal to each other in their lengths. So from point B, if we draw the first tangent AB, and we will draw also the second tangent to the circle, that is BX, then the lengths of those two tangents are equal to each other, that is to say AB equals to BX. So that is two tangents theorem. And for that reason, we know that AB equals to BX. Okay, so actually we proved that all the sides of triangle PBX are equal to all the sides of the green triangle, triangle APB. Therefore, we actually proved that the green triangle, triangle APB, is congruent to the white triangle, triangle PBX, according to side rule. Okay, so I write it down. So triangle APB, the green triangle, is congruent to triangle PBX, the white triangle, according to side rule. I will read again the things that I wrote. So triangle APB is congruent to triangle PBX according to side rule. What is side rule? Side rule states that if you prove that all the sides of one triangle congruent to all the sides of another triangle, then those two triangles congruent to each other. Okay? So we proved the triangle APB is congruent to triangle PBX. Therefore, from the fact that those two triangles congruent to each other, we can derive that this angle that equal to theta according to our definition equals to this angle. It is actually angle PBX. Okay, so we can derive from the fact that those two triangles can go into each other that angle ABP equals to angle PBX. Okay, angle APB equals to angle PBX. And we know that angle APB equals to theta. We know that angle APB equals to theta, so from this equality we can derive that angle ABP also equals to theta. Okay, we know that angle ABP equals to theta, therefore angle PBX will be also equal to theta. Actually, those two angles are equal to each other according to the rule that corresponding angles in congruent triangles are equal to each other. Okay, I write it down. Corresponding angles in congruent triangles are equal to each other. So I'll read again the things that I wrote. So angle ABP equals to angle PBX according to the rule that corresponding angles in congruent triangles are equal to each other. We know that triangle ABP, the green triangle, equals to triangle PBX. So those two triangles can go into each other, therefore the corresponding angles, that is to say angles ABB and angles PBX, will be also equal to each other. Okay? So in the next step we will extend line segment CB and the radius DO until they intersect each other. And we will define the intersection point between line segment CB and the radius DO as point E. Again, point E is the intersection point between line segment CB and the radius DO. Okay? And in the next step, we will complete the quarter circle to a semicircle. Okay? Actually, by extending line segment CB and line segment DO, we created here two vertex angles. Angles EBO, this angle, and angle ABC are two vertex angles. So I write it down. Angle ABC and angle BOE, angle EBO, this angle and this angle are two vertex angles, so are vertex angles. Okay, so I will draw those two vertex angles again in order to clarify the issue. It will be more clear. the two angles in the red color, angle ABC and angle EBC, angle EBO, this angle, and angle ABC are two vertex angles. Those two angles are two vertex angles, and we have a rule. The rule states, actually before that, what is the value of angle ABC? Angle ABC equals to theta plus theta. That is to say, angle ABC equals to 2 theta. Okay, so I will talk about the rule. The rule states that vertex angles are equal to each other. Again, the rule states that vertex angles are equal to each other. Therefore, according to this rule, those two vertex angles are equal to each other. That is to say, angle ABC is equal to the vertex angle EBO, and those two angles are equal to each other. So if angle ABC equals to 2 theta, then angle EBO will be also equal to 2 theta. From this equality we can derive that angle EBO also equals to 2 theta. So we can, in the drawing, we can write that this angle equals to 2 theta because of the fact that those two vertex angles are equal to each other, and angle ABC equals to 2 theta, so this angle also equals to 2 theta. Okay, so actually angle ECD equals to 90 degrees. It is given us in the question. And again, angle ECD, this angle equals to 90 degrees. And actually, angle ECD is a peripheral angle. Why? Because it is located inside the quarter circle. Okay, angle ECD that equals to 90 degrees is a peripheral angle. Okay. Angle ECD that equals to 90 degrees is a peripheral angle because of the fact that it is located inside the quarter circle. Okay, actually the vertex of angle ECD is on the quarter circle on point C. Okay, and we have a rule the rule states that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. I will read the rule again. The rule states that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. So we know that the peripheral angle ECD equals to 90 degrees. Therefore, angle ECD rests on the diameter of the circle. We know that angle ECD rests on ED. Therefore, according to this rule, ED is the diameter of the circle, or ED is the diameter of the quarter circle. So according to this rule, we can derive from this rule that ED is the diameter of the quarter circle and also the semicircle of the semicircle. Okay, according to this rule, ED is the diameter of the semicircle, and we know that any diameter equals to 2 times the radius of the circle. So ED, that is the diameter of the semicircle and also the diameter of the quarter circle, equals to 2 times the radius of the semicircle and the quarter circle, equals to 2r. And what is the size of OE? OE equals to DE minus DO. Again, OE equals to DE minus DO. Okay. Again, OE equals to DE minus DO. Okay. OE, line segment OE equals to DE minus DO. We know that DE equals to 2R and DO equals to R, so 2R minus R equals to R. So OE is the radius of the semicircle. And we know that the radius of the semicircle equals to 3 units. Okay? So we know that DE is the diameter of the semicircle. Therefore, DE is a straight line. DE is the diameter of the semicircle, is a straight line. Again, DE is a straight line. we have a rule that states that the sum of the angles on a straight line is equal to 180 degrees. I will read the rule again. The rule states that the sum of the angles on a straight line is equal to 180 degrees. So, because of the fact that DE is a straight line, the sum of the angles on a straight line DE equals to 180 degrees, and especially if we focus at point O on the straight line DE, the sum of the angles at point O on the straight line DE must be equal to 180 degrees. So, what are the angles at point O? We have this angle that equals to 90 degrees plus the size of this angle that is actually angle EOB. So the sum of those two angles must be equal to 180 degrees according to the rule that I stated. So 90 degrees plus angle EOB must be equal to 180 degrees. So from this equality we will subtract 90 degrees and we will get that the size of angle EOB equals to 180 degrees minus 90 degrees is 90 degrees. So we found out that angle EOB is the right angle, that is to say it equals to 90 degrees. So if angle EOB is the right angle, then triangle EOB is the right triangle. Okay? And what are, so we'll focus on the right triangle, triangle EOB. We know that the sum of the angles in any triangle equals to 180 degrees, and especially the sum of the angles in triangle EOB must be equal to 180 degrees. So 90 degrees plus 2 theta plus the size of this angle must be equal to 180 degrees. So we'll write it down, 90 degrees plus 2 theta plus angle OEB must be equal to 180 degrees. Again, in the right triangle, triangle EOB, the sum of the angles is equal to 180 degrees, that is to say 90 degrees plus 2 theta plus angle EOB must be equal to 180 degrees. Here we will subtract 90 degrees from this equality, and we will get that 2 theta plus angle OEB, angle OEB equals to 180 degrees minus 90 degrees is 90 degrees. here we will subtract 2 theta from this equality, and we will get that the size of angle OEB is actually 90 degrees minus 2 theta. Okay, so the size of this angle OEB, is 90 degrees minus 2 theta. Okay, so in the next step we will focus on the right triangle, the right big triangle, triangle DCE. So in triangle DCE, the right triangle DCE, again in any triangle the sum of the angles is equal to 180 degrees, and especially in the right triangle, triangle DCE, the sum of the angles is equal to 180 degrees. So what is the sum of the angles in the right triangle, triangle DCE? Actually, the size of this angle, that is angle EDC, plus this angle that is 90 degrees, plus this angle that is 90 degrees minus 2 theta, the sum of those three angles must be equal to 180 degrees. Okay, in the right triangle, triangle EDEC, the sum of the angles is equal to 180 degrees. So here we have 90 degrees plus 90 degrees is 180 degrees. Here we have 180 degrees in this side of the equality, and we have 180 degrees on the other side of the equality. So 180 degrees will get cancelled. Okay, so here what is left is only 0, and what is left here is angle EDC minus 2 theta equals to 0. So here we will add 2 theta to this equality, and we will get that angle EDC equals to 2 theta. So we found out that angle EDC this angle equals to 2 theta. Okay, so we will continue to focus on the right triangle, triangle EDC. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, CD squared plus CE squared equals to DE squared. Okay. Again, in the right triangle, triangle CDE, the square of the hypotenuse equals to the sum of the square the squares of the perpendiculars, that is to say CD squared plus CE squared equals to DE squared. What is the value of CD? CD equals to 2 units. It is given us in the question. So CD squared is 2 squared, 2 squared is 4. Plus CE squared equals to DE squared. What is the size of DE? DE is the diameter of the semicircle. That is to say it equals to 2 times the radius of the semicircle, and the radius of the semicircle equals to 3 units. So 2r is 2 times 3, that is to say it equals to 6. So DE squared is 6 squared, 6 squared is 36. So in total we got that 4 plus CE squared equals to 36. Here we will subtract 4 from this equality and we will get that CE squared equals to 36 minus 4 is 32. So here we'll take a root out of this equality and we will get that CE equals to the root of 32. But 32 equals to 16 times 2. And the root of 16 is 4. So we found out that the value of CE is 4 times root 2 units, okay? CE equals to 4 times root 2 units. We will continue to focus on the right triangle CDE. In the right triangle CDE, tangents 2 theta equals to CE over CD. Okay, on the right triangle CDE, tangents 2 theta equals to CE over CD. But we have already found out that CE equals to 4 times root 2. And CD equals to 2 units. So we can write down that tangents 2 theta equals to 4 times root 2 over 2. Okay? Tangents 2 theta equals to 4 times root 2 over 2. 4 over 2 is 2, so in total we found that tangents 2 theta equals to 2 times root 2. Tangents 2 theta equals to 2 times root 2. We know that the radius of the small circle equals to AB times tangents theta. So we have to find out the value of tangents theta, and we know that the value of tangents 2 theta is 2 times root 2. So in order to find out the value of tangents theta from the value of tangents 2 theta, I will present to you a new trigonometric identity, and from that trigonometric identity we will find out the value of tangents theta. The trigonometric identity states that tangents 2 theta equals to 2 tangents theta over 2 tangents tangents 2 theta equals to 2 tangents theta. Again, tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. So the trigonometric identity is tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. So we know that tangents 2 theta equals to 2 times root 2. So we can substitute tangents theta in the trigonometric identity by 2 times root 2. Okay? So we substitute tangents 2 theta by 2 times root 2. We get that it equals to 2 tangents theta over 1 minus tangents square theta. Okay, we got this equality. So here we will define tangents theta as x, that is to say tangents theta equals to x. Okay, so we define tangents theta as x. Then we will substitute tangents theta in this equality by x, and we will get that 2 times root 2 equals to 2 tangents theta is 2x over 1 minus tangents square theta is x squared. So we got this equality. 2 times root 2 equals to 2x over 1 minus x squared. Here we multiply this equality by 1 minus x squared, and we will get that 2 times root 2 equals to 2 times root 2 times 1 minus x squared equals to 2x. Here we will divide this equality by 2, and we will get that root 2 times 1 minus x squared equals to x. So here we will open the brackets. We will get that root 2 minus root 2 x squared equals to x. Here we will add to this equality root 2 x squared. We will get that root 2 equals to root 2 x squared plus x. We will subtract root 2 from this equality, and we will get that root 2 x squared plus x minus root 2 equals to 0. So we got here quadratic equation. We have here quadratic equation, and we know that the general formula for a quadratic equation is ax squared plus bx plus c equals to 0 when a, b, and c are the coefficients of the quadratic equation and x is the variable that we want to find out. And we will find out the value of x according to a special formula. According to this formula, x equals to minus b plus minus root b squared minus 4 times a times c over 2a. So a, b, and c are the coefficients of the quadratic equation and x is the variable that we want to find out. So in our specific quadratic equation, this equation, we know that a equals to root 2 b equals to 1 and c equals to minus root 2. Okay, a equals to root 2, b equals to 1, and c equals to minus root 2. So we will put this data inside the formula for x, and we will find out the value of x that is actually equal to tangent theta. So we will get that x equals to minus b, b is 1, so minus b is minus 1, plus minus root of b square is 1 square, 1 square is 1, minus 4 times a is minus 4 times root 2, times c is times minus root 2 over 2a over 2 times root 2. Okay, so we got that x equals to minus 1 plus minus 1. First of all, minus times minus is plus, and root 2 times root 2 is 2, and 2 times 2 is 2 root 2 times root 2 is 2, and 2 times 4 is 8. 8 plus 1 is 9. Okay. So we got this. So here the root of 9 is 3. So I write it down. X equals to minus 1 plus minus 3 over 2 times root 2. Okay, so here we have two solutions. The first solution is x equals to minus 1 minus 3 over 2 times root 2. X equals minus 1 minus 3 is minus 4 over 2 times root 2. And minus 4 over 2 is minus 2 over root 2. So we found out that x equals to minus 2 over root 2. That is negative number, it's less than 0. So we found out x is tangent theta. So we found out that tangent theta is actually negative. Tangent theta is negative. But we actually have here the right triangle with angle theta. So I will draw it again. Okay, so I draw the right triangle with angle theta. We know that the sum of the angles in any triangle equals to 180 degrees. So here angle APB plus 90 degrees plus theta equals to 180 degrees. We'll subtract 90 degrees from this equality and we will get that angle APB plus theta equals to 90 degrees. Here we will subtract angle APB from this equality and we will get that angle theta equals to 90 degrees minus angle APB. So angle theta equals to 90 degrees minus APB, that is to say, is less than 90 degrees. Because 90 degrees minus angle APB is less than 90 degrees. So angle theta is less than 90 degrees. If angle theta is less than 90 degrees, then x, that is tangent theta, must be positive number. It's greater than 0. Okay, so here we found out that x, that is tangent theta, is a positive number, while according to our solution, x that equals to tangent theta is negative. So here we found that according to our solution, x is, that is tangent theta, is negative, while here, according to our data, x must be a positive number. Therefore we have here a contradiction. Therefore this answer is incorrect answer, and we only left with the answer, with the solution that x equals to minus 1 plus 3 over 2 times root 2. Minus 1 plus 3 is 2, and 2 over 2 times root 2 equals to 1 over root 2. So x equals to 1 over root 2, but x equals to tangent theta, so tangent theta equals to 1 over root 2. So we found out the tangent theta equals to 1 over root 2, and we have already found out the tangent to theta equals to 2 times root 2. Okay? Again, we know that the radius of the small circle equals to AB times tangent theta. And we have already found out that tangent theta equals to 1 over root 2. So the only thing that is left to find, in order to find out the radius of the small circle, is to find out the value of AB. Okay? To find out the value of AB. So, in the next step, we will focus on the right triangle BOE. So, in the right triangle BOE, we know that tangent to theta equals to OE over BO, or equals to EO over BO. Okay, in the right triangle BOE, tangent to theta equals to EO over BO. But we know that EO equals to 3 units. So it is 3 over BO. Okay? So tangent theta equals to 3 over BO because EO equals to 3. But we have already found out that tangent to theta equals to 2 times root 2. So we can substitute tangent to theta by 2 times root 2. We get that 2 times root 2 equals to 3 over BO. Here we will multiply this equality by DO, and then we will divide it by 2 times root 2, and we will get that BO equals to 3 over 2 times root 2. Okay, so we found out that BO equals to 3 over 2 times root 2. Okay, BO equals to 3 over 2 times root 2. So, in the next step, we'll join together points P and O by straight line. So we join together points P and O by a straight line. Actually, triangle APO is a right triangle because of the fact that angle OAP is a right angle. In the next step, we will extend the hypotenuse OP until it touches the two circles at point M. Okay. point M is the touching point between the small circle with the semicircle, and point M is also the point that the hypotenuse OP arrives after we extended the hypotenuse OP. We actually extended the hypotenuse OP until it arrives to point M, that is the touching point between the small circle with the semicircle. Okay, so what is the size of MP? MP is actually the radius of the small circle, because of the fact that it starts from the center of the small circle and touches the small circle at point M. Okay, so MP is small r, the radius of the small circle. And what is the value of MO? You should remember that O is the center of the semicircle, and M is a point on the semicircle itself, so MO is the radius of the semicircle. The semicircle and the quarter circle also. So we found out that MP is the radius of the small circle, while MO is the radius of the MP is the radius of the small circle, and MO is the radius of the semicircle. So what is the size of OP? OP, from the drawing we can see that OP equals to OM minus MP. Again, OP equals to OM minus MP. OP equals to OM is the radius of the small circle of the semicircle, minus MP is the radius of the small circle. So in total we got that OP equals to capital R minus small r. But capital R, the radius of the semicircle, is 3 units. So we can write here that OP equals to 3 minus R. OP equals to 3 minus R. So in the right triangle APO, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AP square plus AO square equals to PO square. Again, in the right triangle APO, according to the Pythagoras theorem, AP square plus AO square equals to PO square. What is the value of AP? AP equals to small r. So AP square is r square plus AO square equals to PO square. We have already found out that PO equals to 3 minus r. So PO square will be equal to 3 minus r square. So in total we got this equality. Here we will open the brackets in this expression, and we will get that r square plus AO square equals to 9 plus r squared minus 6r. Okay. So here we have r squared in this side of the equality, and we have r squared on the other side of the equality, so r squared will get cancelled. And what is left after we cancelled r squared? Actually, what is left is a all squared equals to 9 minus 6r. Okay. A all squared equals to 9 minus 6r. Here we will take a root out of this equality, and we will get that AO equals to the root of 9 minus 6r. So we found out that AO equals to the root of 9 minus 6r, and we have already found out that BO equals to 3 over 2 times root 2. BO equals to 3 over 2 times root 2. Okay? So we found out the values of AO and BO. But what is the value of AB? From the drawing we can see that AB equals to AO minus BO. Again, AB equals to AO minus BO. AO minus BO. Okay, AB equals to AO minus BO. We have already found out the values of AO and BO. So we will substitute AO by its value and BO by its value, and we will get that AB equals to AO. AO is the root of 9 minus 6r, and minus BO. BO equals to 3 over 2 times root 2. So we found out the value of AB. We know the value of AB, and we have already found out the tangent theta equals to 1 over root 2. So we found out the values of AB and tangent theta, and we know that the radius of the small circle equals to AB times tangent theta. We know that the radius of the small circle equals to AB times tangent theta. So we will substitute AB by its value, and we will substitute tangent theta by 1 over root 2. Okay, so R will be equal to AB. This is the value of AB. Root of 9 minus 6R minus 3 over 2 times root 2. And the value of tangent theta is 1 over root 2. Okay? So this is what we got after we substituted AB by its value, and after we substituted tangent theta by 1 over root 2. Here we will multiply this equality by root 2. So in this equality we will add 3 over 2 times root 2 to this equality, and we will get that 2 times r plus 3 over 2 times root 2 equals to the root of 9 minus 6r. So here we will multiply this equality by 2 times root 2, and then we will divide it by 2 times root 2 in order to have a common factor with this expression. So we will get that root 2 times r times 2 times root 2 over 2 times root 2 plus 3 equals to the root of 9 minus 6r. Okay, this is what we got. Okay, so here we have root 2 times root 2 is 2, and 2 times 2 is 4. In total, we will have here 4r plus 3 in the numerator. So here we will square this equality. That is to say, we will square both sides of this equality, and we will get that 4r plus 3 squared over 2 times root 2 squared is 8 equals to the, here we have root of 9 minus 6r. We square the root. When we square the root is cancelled because the square cancels the root. Okay, so what is left is only 9 minus 6r. Here we will multiply this equality by 8, and we will get that 4r plus 3 squared equals to 8 times 9 is 72, and 8 times minus 6r is minus 84r. Okay? So here we will open the brackets in this side of the equality, and we will get that 16r squared plus 9 plus 4r times 3 is 12r, 12r times 2 is 24r, equals to 72 minus 48r. Okay. Okay, so here we will add to this equality 48r. We will get that 16r squared plus 9, 48 plus 24 is 72. Here we will subtract from this equality 72. We will get that 16r squared plus 72r. 9 minus 72 is minus 63 equals to 0. So we have here a quadratic equation, and the coefficients of this quadratic equation are a equals to 16, b equals to 72, and C equals to minus 63. And the solution for a quadratic equation is x equals to minus b plus minus root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, the variable is r, so x equals to r. So we will put the data inside x in order to find out the value of r. Then inside the formula for x, the general formula to find out the value of x for x, the general formula for x. So we get that x equals to r equals to minus b. B is 72, so minus b is minus 72 plus minus root of b squared. 72 square is 5,184 minus 4 times AC, minus 4 times 16 is minus 64, minus 64 times minus 63 is plus 4,032. All divided by 2a. A is 16, so 2a is 32. So in total we got 3. We have this equality. In the root we have 5,184 plus 4,032 is 9,216. R equals to minus 72 plus minus root of 9,216 over 32. And the root of 9,216 is 96 over 32. So the first solution for R is R equals to minus 72 minus 96 over 32. Minus 72 minus 96 is minus 168 over 32. It equals to minus 5.25. So we found out that the radius of the small circle equals to minus 5.25. But because of the fact that the radius of any circle must be a positive number, and we found out negative number, this answer is not correct, this solution is incorrect, and we only left with the solution that R equals to minus 72 plus 96 over 32. And minus 72 plus 96 is 24, and 24 over 32 is 3 over 4, or 0.75. So R equals to 3 over 4, or 0.75 units. Okay, so the radius of this circle equals to 3/4 units, so 0.75 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the radius of this small circle. This small circle is inside a quarter circle. We know that this angle equals to 90 degrees, angle BCD equals to 90 degrees, chord CD equals to 2 units, and DO equals to 3 units, and we want to find out the radius of the small circle. Okay? So, first of all, because of the fact that we have a quarter circle, we know that O is the center of the circle and OD is the radius of the quarter circle, and we also know that angle DOB equals to 90 degrees. Okay, then we define the center of the small circle as point P, and we connect it together by a straight line points A and P, and actually AP is the radius of the small circle because of the fact that it starts from the center of the small circle and ends at point A, that is a point on the small circle itself. Therefore, AP is the radius of the small circle. And we actually have a rule. Here we have tangent AB to the circle, to the small circle. Tangent BA is tangent to the circle at point A. And we have a rule that states that the tangent to the circle is perpendicular to the radius at the point of tangency. Again, the tangent to the circle is perpendicular to the radius at the point of tangency. So, if we have a circle and we have tangent to this circle at point X, and we have the radius that is drawn to the point of tangency, that is to say to point X, then according to the rule that I stated, this radius is perpendicular to the tangent, that is to say this angle equals to 90 degrees. So the rule is that the radius is always perpendicular to its tangent. Again, the radius is always perpendicular to its tangent. So if this is the radius, then the tangent to this radius is this tangent, and the radius and the tangent touch each other at point X, and the radius is always perpendicular to its tangent. That is to say, this angle is 90 degrees. And for that reason, angle BAP is 90 degrees, because the tangent AB is perpendicular to the radius. Therefore, this angle is 90 degrees. Okay? And so in the right triangle, triangle APB, we can say that tangent theta equals to AP over AB. Tangent theta equals to AP over AB. But we know that AP equals to the radius, so tangent theta equals to R over AB. We multiply this equality by AB, and we got that R equals to AB times tangent theta. Okay, so in order to find out the radius of the small circle, we must find out the value of AB and the value of tangent theta. Then we actually proved, first of all, we defined the touching point between line segment CB and the circle is point X, and then we connected together points P and X by a straight line. And then we proved that triangles ABP and triangle PBX are congruent to each other. I drew these two triangles again. I proved that the green triangle is congruent to the white triangle. Actually, AP equals to PX, because both those line segments are the radiuses of the small circle, therefore they are equal to each other. And PB is a common side. It belongs both to the small triangle, it belongs both to triangle APB, and PB also belongs to triangle PBX. So it is a common side. So PB equals to PB, and also AB equals to BX. AB equals to BX. So why AB equals to BX? You can see that AB is tangent to the circle at point A, and BX is tangent to the same circle at point X. And we have the two tangents theorem that states that the lengths of two tangents from a common external point to a circle are equal. So if from a common external point you draw two tangents to the same circle, that is to say the external point is B. From point B you draw two tangents to this circle, to the small circle, tangent AB and tangent BX. So that two tangents that exited from a common external point, that is to say from point B, and touches the circle at points A and X, actually they are equal to each other by their lengths. That is to say AB equals to BX. So we actually proved that all the sides of the green triangle are equal to all the sides of the white triangle. So we actually proved that triangle APB is congruent to triangle PBX according to side rule. What is side rule? Side rule is that when you prove that all the sides of one triangle congruent to all the sides of the other triangle, then those two triangles congruent to each other according to side rule. Okay, from the fact that those two triangles congruent to each other, we can derive that angle ABP equals to angle PBX. Okay, angle APB equals to angle PBX, and if angle ABP equals to theta, then angle PBX will be also equal to theta. So this angle also equals to theta, and the reason that those two angles are equal to each other is according to the rule that corresponding angles in congruent triangles are equal to each other. Okay? Then we extended line segment CB and also the radius DO until they touch each other or until they intersect each other at point E. Okay? By extending those two line segments, we created two vertex angles, angle ABC, and angle EBO are two vertex angles. So I drew them again. The angles that I marked with the red line are two vertex angles. This angle ABC is a vertex angle, and this angle EBO are also vertex angles. And we have a rule that vertex angles are equal to each other. That is to say, angle ABC is equal to angle EBO. Okay? Angle ABC equals to angle EBO, and if angle ABC equals to 2 theta, then angle EBO will be also equal to 2 theta. That is to say, this angle equals to 2 theta. Okay? So here this angle equals to 2 theta, and then I completed the quarter triangle to a semicircle, and then actually angle ECD, this angle is a peripheral angle. Why it is a peripheral angle? Because it's located in the circle. Okay? Okay? So we have here angle ECD, that is a vertex angles. Angle ECD is a vertex angle. And we have a rule about vertex angle. The rule is that any peripheral angle, actually angle ECD is not a vertex angle but a peripheral angle. Angle ECD is a peripheral angle because of the fact that it is located inside the quarter circle. Again, angle ECD is a peripheral angle because of the fact that it is located in the quarter circle. Okay? And we have the rule that any peripheral angle that equals to 90 degrees rests on the diameter of the circle. Okay? So, peripheral angle ECD that equals to 90 degrees must rest on the diameter of the circle. That is to say, DE is the diameter of the quarter circle and also the semicircle. Okay? According to the rule that I stated, DE is the diameter of the semicircle and the quarter circle itself. Okay? And what is the size of OE? We know that the diameter of any circle equals to 2 times the radius, so DE equals to 2R. and DO equals to R. And what is the size of OE? OE equals to DE minus DO. OE equals to DO. OE equals to DE minus DO. Again, OE equals to DE minus DO. Okay? DE minus DO, but DE equals to 2R and DO equals to R. So OE equals to 2R minus R, that is to say equals to R. OE equals to R, and then in triangle DE is the diameter of the semicircle, therefore DE is a straight line. Okay, and we have the rule that the sum of the angles on a straight line is equal to 180 degrees. Okay, and especially the sum of the angles of the right, the straight line DE equals to 180 degrees, and especially if we focus on point O, the sum of the angles on the straight line DE must be equal to 180 degrees. What is the sum of the angles on the straight line DE? The sum of the angles on the straight line DE at point O will be equal to 90. This angle is 90 degrees plus angle EOB must be equal to 180 degrees according to the rule that I stated. 90 degrees plus angle EOB equals to 180 degrees. Here we subtracted 90 degrees from this equality and we got that angle EOB equals to 90 degrees. So this angle EOB is the right angle. Okay? And we know that the sum of the angles in any triangle is equal to 180 degrees, and especially in the right triangle, triangle EOB, the sum of the angles is equal to 180 degrees. That is to say 90 degrees plus 2 theta plus the size of angle OEB must be equal to 180 degrees. Again, in the right triangle, triangle EOB, 90 degrees plus 2 theta plus the size of angle OEB must be equal to 180 degrees. Here we subtracted 90 degrees from this equality and we got 2 theta equals to angle EOB, 2 theta plus angle EOB equals to 90 degrees. We subtracted 2 theta from this equality and we got that angle OEB equals to 90 degrees minus 2 theta. This angle OEB equals to 90 degrees minus 2 theta. Then we focused on the right triangle DCE. You know that the sum of the angles in any triangle, and especially in triangle DCE, equals to 180 degrees. That is to say, the size of angle EDC plus 90 degrees plus 90 degrees minus 2 theta equals to 180 degrees. Okay, angle EDC plus 90 degrees plus 90 degrees minus 2 theta equals to 180 degrees. Here we subtracted 180 degrees from this equality, and we got that the size of angle EDC equals to 2 theta. The size of this angle is 2 theta. We continue to focus on the right triangle, triangle EDC. You know that in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars according to the Pythagoras theorem. So in the right triangle ECD, CD square plus EC square equals to DE square. Okay? CD square plus CE square equals to DE square. We know that CD equals to 2, so CD square equals to 4, plus CE square equals to DE square. What is the size of DE? DE equals to 2R, and R equals to 3, so 2R is 2 times 3 is 6. DE equals to 6. So DE square is 6 square. 6 square is 36. So here we will get that 4 plus CE square equals to 36. We subtracted 4 from this equality and we got that CE square equals to 32. We took a root out of this equality and we got that CE equals to 4 times root 2. Then we continue to focus on the right triangle DCE. We know that tangent 2 theta equals to CE over CD. Tangent 2 theta equals to CE over CD, but we have already found out that CE equals to 4 times root 2. And CD equals to 2, it is given us in the question. So we found out that tangent 2 theta equals to 2 times root 2. Okay? Tangent 2 theta equals to 2 times root 2. And we have the equality that the radius of the small circle equals to AB times tangent theta. So in order to find out the radius of the small circle, we must find out the value of tangent theta. But we have only the value of tangent 2 theta. So in order to find out the value of tangent theta from tangent 2 theta, I presented to you a new trigonometric identity. And from this trigonometric identity, we will find the value of tangent theta from tangent 2 theta. The trigonometric identity is tangent 2 theta equals to 2 tangent theta over 1 minus tangent square theta. We know that tangent 2 theta equals to 2 times root 2, so we can substitute tangent 2 theta by 2 times root 2. So we substituted tangent 2 theta by 2 times root 2, we got this equality. Then we defined tangent theta as x, so we substituted tangent theta by x. And we got this equality. From this equality, we actually got quadratic equation. We got this quadratic equation. We solved this quadratic equation and we found out that x equals to 1 over root 2. X equals to 1 over root 2, but x equals to tangent theta according to our definition, so tangent theta equals to 1 over root 2. We've already found out that tangent 2 theta equals to 2 times root 2. We have the equality that r equals to AB times tangent theta. So we have already found out the value of tangent theta. Tangent theta equals to 1 over root 2. So the only thing that is left to find in order to find out the radius of the small circle is to find out the value of AB. Okay? So we focused on the right triangle, triangle EOB. On the right triangle, triangle EOB, we know that tangent 2 theta equals to OE over OB. OE equals to 3, and OB is OB. On the right triangle BOE, tangent 2 theta equals to EO over BO. EO equals to 3. So we will get the tangent 2 theta equals to 3 over BO. We have already found out that tangent 2 theta equals to 2 times root 2, so we substituted tangent 2 theta by 2 times root 2. We got this equality. From this equality, we got that BO equals to 3 over 2 times root 2. BO equals to 3 over times root 2. Over 2 times root 2. Then we join together points P and O by a straight line. So the red line, we join together by the red line points P and O. Actually, triangle APO is a right triangle because of the fact that angle POOAP is equals to 90 degrees. Then we extended the hypotenuse OP until it touches the two circles at point M. Point M is the touching point between the small circle and the semicircle, and it is also the point that we extended OP until it touches the two circles at point M. And what is the size of MP? MP is the small radius equals to small r. What is the size of MO? MO equals to capital R, is the radius of the semicircle. Okay, MP equals to small r and MO equals to R. And what is the value of OP? OP equals to MO minus MP. Again, OP equals to MO minus MP. OP equals to MO minus MP. We have already found out that MO equals to capital R and MP equals to small r. And we know that capital R equals to 3 units. So in total we found out that OP equals to 3 minus R. Okay, so in the right triangle, so OP equals to 3 minus small r and AP equals to small r. So in the right triangle, triangle APO, according to the Pythagoras theorem, AP square plus AO square equals to PO square. AP square plus AO square equals to PO square. And AP equals to R, so AP square equals to R square plus AO square equals to PO square. PO is 3 minus R, so PO square is 3 minus R square. We opened here the brackets and we found out that AO equals to the root of 9 minus 6R, and we have already found out that VO equals to 3 over 2 times root 2. And what is the size of AB? AB equals to AO minus BO. Again, AB equals to AO minus BO. Okay, AB equals to AO minus BO. So AB equals to AO, this is the value of AO, minus BO, this is the value of BO. So we found out that AB equals to this expression, and we have already found out that times 2 theta equals to 1 over root 2. And we have the equality that the radius of the small circle equals to AB times tangent theta. So we will substitute AB by the value that we found for AB by this expression, and we will substitute tangent theta by 1 over root 2, because tangent theta equals to 1 over root 2. So we substituted AB and tangent theta by their values. We got this equality. We solved this equality, and we arrived to a quadratic equation. This quadratic equation, we solved this quadratic equation, and we found out that the radius of the small circle equals to 3 over 4 units, or 0.75 units. Again, the radius of this small circle equals to 3 over 4 units, so it equals to 0.75 units. Okay, thank you very much.